Everyone, this is your math guru. In this video, I'm going to show you how to solve the following quadratic inequalities. Please don't forget to click on the like and the subscribe button below for more easy to understand math concepts. In the first example, we have p squared minus 5p plus 4 is less than 0. The first check is to make sure that our inequality equation is written like a quadratic equation, meaning we have all the terms on one side equal to 0. So we are taking a less than sign here to be similar to our equal sign. And when you have a quadratic equation, how do you solve that? We solve by, first of all, factorizing what we have, and then you find the values. So the first step is to factorize a left-hand side. We have less than 0. P squared minus 5p plus 4, if we factorize, will give us p minus 4, p minus 1. The next step is to find our critical values. The critical values will help us with our case analysis. So we have p minus 4 equals to 0. Ignore the inequality sign for now. And then we have p equals minus 4 to the other side, positive 4. Likewise, we have p minus 1 equals to 0. Then taking a negative 1 to the right-hand side, we have p equals to positive 1. 4 and 1 in this case are the critical values. The next step is to test these values on a number line, and that will be a case analysis. So therefore, using the number line as shown, we have 0.1 and 0.4. We need to test point before, in between, and after, such that the inequality p minus 4 multiplying p minus 1 would be less than 0. So we have, this is going up to negative infinity, and this to positive infinity. If you test a number less than 1, let's say we're testing 0, for example, if you go back to our equation, we have 0 minus 4 in the first bracket. That will definitely give us a negative value. So what that means is numbers less than 1 will give us a negative value in the first bracket, and going to the second bracket, if you put as 0, 0 minus 1, that will also give us a negative value. So in summary, numbers less than 1 will give us a negative value in the first bracket and also a negative value in the second bracket, such that we have minus times minus, that's plus. A positive value is not less than 0. So what that means is at that point, numbers less than 1 is not true. I'm going to put the X to show that is not true for that inequality. Then the next step is to test numbers between 1 and 4. I'm not going to test 1 and 4 because my inequality sign says less than. There's no equality sign, so I'm not testing points 1 and 4. The next step is to test a point between 1 and 4. Let's say I'm testing 3, which is a number between 1 and 4. If I go to the first bracket, 3 minus 4, values in that region will give us a negative number in the first bracket, and in the second bracket that will be positive because 3 minus 1 is positive 2. If I multiply minus and positive, it's going to give us a negative value, and note that this is true because a negative value is less than 0. So what that means is in this region, numbers greater than 1 but less than 4, our inequality is true. So I'm going to give it a tick sign. The last set of numbers I'm testing are numbers greater than 4. So let's say I'm testing 0.5, which is a number greater than 4. I go back to my equation and then slot in 5. The first bracket, I'm going to have a positive value because numbers greater than 4, 5 for example, 5 minus 4 will give me a positive value. In the second bracket, 5 minus 1 is also positive. So what that means is numbers greater than 4 will give me positive values in the 2 bracket. And if I multiply plus times plus, it's also equal to plus, which is not a value less than 0. So if I go back to our case analysis using the number line, it simply means that numbers greater than 4 is not true at this point. So therefore, we have numbers not equal to 1, but numbers greater than 1 in this direction. And then we have, going to draw that again, numbers from 4 not equal to 4, but less than 4. So writing that as an interval notation, we're going to have P is greater than 1 and P is less than 4. I can put that together as 1 is less than P, but P is less than 4. Or I write it as P is an element of, we're starting from 1. 1 is not included, so that's going to be a curve bracket or curly bracket. That's from 1 to 4. 4 is not included, so that's not going to be a square bracket as shown. Let's look at the second example. In our second example, we have x multiplying x minus 1 less or equal to 20. The first step is to rewrite as a standard quadratic equation. So we're going to start by expanding the bracket. X times x, that's x squared. X times negative 1, that's minus x, less or equal to 20. I want to make the right-hand side equal to 0. So that will be x squared minus x minus 20 less or equal to 0. Now that we've written it like a standard quadratic equation, I'm going to simplify or solve by factorizing what we have on the left-hand side, less or equal to 0. So I have that as x minus 4, x, that will be x plus 5. I'm going to swap that around because I have negative x in the middle, so that's x minus 5, not minus 4. Then x plus 4. Now that we've gotten our values, or we've factorized, the next step is to find the critical values. So critical values, we assume an equality sign is equal to 0. So we have x minus 5 equals to 0. Therefore, x equals to 5. And the second critical value, we have x plus 4 equal to 0. Taking our positive 4 to the right-hand side, that will become negative 4. So we have 5 and negative 4 to be our critical values, UES. The next step, I'm going to correct the spelling. The next step is to do our case analysis using our number line. So if I draw my number line as shown, I have this to negative infinity and this to positive infinity. I have point negative 4 and point 5. The first point I'm going to test are points less than negative 4. So assuming I'm testing negative 5, if I go back to our equation, put in negative 5 in the first bracket, negative 5, that will give me a negative 10, which is a negative value. In the second bracket, numbers less than negative 4 will also give me a negative value in the second bracket. Negative 5 plus 4, that's negative 1. If I multiply minus times minus, that's positive. A positive value is not less than 0. So what that means is, for numbers less than negative 5, the inequality is not true at that point. The next step is to test numbers greater than negative 4 but less than 5. Note that numbers negative 4 and 5 will give me a 0 for our equation. If you go back and test those points, so I'm not going to test that again. Negative 4 will give me 0 in my second bracket, which will make that inequality equal to 0. And likewise, if I put my positive 5, it will make the first bracket 0. So therefore, the points 4, or negative 4 rather, and points positive 5 are true for that inequality. Testing the points in between, let's say I have a point O or 0. 0 back into the equation, I have the first bracket, 0 minus 5, that will give me negative 5. So I'm going to have negative in the first bracket. In the second bracket, 0 plus 4 is positive 4. And if I multiply the negative times the positive, it's going to give me a negative value, which is a number less than 0. So what that means is, for numbers between negative 4 and 5, the inequality is true. So I'm going to have a tick as shown. And then the last part is to test numbers greater than 5. So let's say we are testing 6. Taking 6 back, going to take out what I have. 6 in the first bracket will give me a positive value. 6 minus 5, that's 1. 6 in the second bracket, 6 plus 4, that's 10. That's also a positive value. Plus times plus, that's plus. That is not a number less than 0. So what that means is, for value greater than 5, that inequality will not be true. So I only have values from negative 4 to 5 as shown. And if I write it as interval notation, I have x is greater or equal to negative 4 and x is less than or equal to 5 as shown. So that means I have x is an element of, I'm starting from negative 4, and because negative 4 is included because of our inequality, the equality sign under our inequality, we have that as the square bracket to positive 5. So I can also have that as minus 4 is less or equal to x, but x is less or equal to positive 5. Let's look at the last example together. In the last example, we have x squared minus x minus 12 greater or equal to 0. We start, because it's already 0, equal to 0. I'm going to start by factorizing my left-hand side. I have greater or equal to 0, so I have that as x minus 4, x plus 3. The next step is to find our critical values. So I have x minus 4 equals to 0 for the first bracket. Therefore, x will be equal to 4. And for the second bracket, x plus 3 equals to 0. X equals negative 3. So negative 3 and positive 4 are critical values. The next step is to do our case analysis by testing this point. We are from negative infinity to positive infinity. We are testing point negative 3, positive 4. Because of our equality sign under our sign, I'm not going to test the points minus 3 and 4, because if you check, if I put minus 3 into our equation, already that makes that bracket 0, which is true for what we have on ground. So therefore the point negative 3 is true. And if you test 4 in the first bracket, 4 minus 4 is 0. So that also makes it true for x is equal to 4. Now I'm going to test point less than negative 3. So if I'm testing, for example, a point negative 4, and I go back, negative 4 in my first bracket will give me negative 8. That's a negative value. Negative 4 plus 3 will give me negative 1. So that's also negative in the second bracket. And if I multiply negative times negative, it's going to be positive, which is a number greater than 0. So for numbers less than negative 3, the inequality is true at that point. So I'm going to put my tick sign. The next step is to test numbers between negative 3 and 4. So if I'm testing 0, for example, and I go back to my inequality, 0 in the first bracket will give me a negative value, that's negative 4. 0 in the second bracket is going to give me a positive value, such that if I have minus times plus, I will have minus, which is not a value less than, it's a value less than 0, not greater than 0. So therefore, for values between negative 3 and 4, the inequality is not true at that point. The last point is to test a number greater than 4. Let's say I'm testing 5. Going back to my equation, if I use 5 in the first bracket, it will give me a positive value because 5 minus 4 is positive 1. And using 5 in the second bracket will also give me a positive value because 5 plus 3 is 8. So therefore, plus plus plus, that's positive, times positive, that's positive, which is a value greater than 0. So it's true in that direction, such that if I draw my arrows, I have points from -3 in the negative infinity direction and points from 4 to the positive infinity direction. If I write that as an interval notation, I have x to be less than or equal to -3, or x is greater than or equal to +4. That's a disjoint interval. So if I put that together, I have point from -infinity to -3. -3 is inclusive because of the equality sign. So I'm going to use my box bracket. Union of, I'm starting from 4. 4 is included, so I'm putting my box bracket to positive infinity, close bracket. Thanks for watching. Bye.